Hello! In this video, I'm going to explain how to read the Geologic History of New York State chart that is provided in your reference tables. The first thing you'll probably notice is that the official Earth Science reference tables actually split this chart in half. So right now you're looking at the first half of the chart. This is what you would see in page 8 of your reference tables packet. Here is the second half of the chart. You can find this on page 9 of the reference tables packet. And here is what the two halves look like photoshopped right next to each other. If you've got a hard copy of the reference tables handy, I'd recommend laying these two pieces of paper right next to each other so they line up nice and perfectly. Students, with all that said, let's go over the actual data included on this chart row by row. The Earth is approximately 4.6 billion years old, and that history is divided into some very large chunks of time called eons. Each eon is divided into smaller pieces of time called eras. Each era is divided into even smaller pieces of time called periods, and each period is divided into still smaller pieces of time called epochs. I'd like to call your attention to two columns of numbers, one over here and one over here. These divide up the eons and the eras and the periods and the epochs into millions of years. It's easiest to explain this by way of example. So take a look at the Mesozoic era. According to this document, it began roughly 251 million years ago and ended roughly 65.5 million years ago. Let's go one step further. As you can tell by the chart, the Mesozoic era is divided into three periods. The middle of these was the Jurassic period. According to the chart, the Jurassic period began 200 million years ago and ended 146 million years ago. So now that we have this knowledge, let's figure out exactly where on the geologic timescale a specific prehistoric animal belongs, namely the American mastodon, which, fun fact, used to roam this very state. We now know the American mastodon went extinct approximately 10,000 years ago, at the end of the Pleistocene epoch. That means the American mastodon was a resident of the Pleistocene epoch, which was part of the Quaternary period, which was part of the Cenozoic era, which was part of the Phanerozoic eon. The next column covers sediments/sedimentary rocks, as well as bedrocks. You can use the two insignias here to determine if we have samples of sediments and/or bedrock from particular points in Earth's history. One thing you should be aware of, though, is that this column is only interested in the geologic record of New York State. It doesn't say anything about the rock records of other states or other parts of the world. Before we move on, I want to double back because it looks like I forgot to mention this column right here. Basically, this column offers a synopsis of important events in the history of life on Earth from specific points in time. For example, according to this column, during the Triassic period, Earth saw the earliest dinosaurs and the earliest mammals. Our next column brings us to the second half of the chart, the one that's found on page 9 of your reference tables. This one is titled Time Distribution of Fossils, including important fossils of New York. To make sense of this column, look at the lettered illustrations of prehistoric animals at the bottom of your screen. Let me explain this one by way of example as well. So look at animal G. Under the illustration, you can see the creature's genus name, which is Manticosaurus. But if you go over and find the vertical G bar in the column, it tells you that this animal belongs to a group of creatures called the ammonoids. Now, if we look over to the left a little ways, we can see that the bar labeled G begins in the Devonian period and then terminates at the end of the Cretaceous period. That tells us that the ammonoids first evolved in the Devonian and then went extinct at the end of the Cretaceous. Both of those facts, by the way, are corroborated by the descriptions written under the Life on Earth column. Okay, so what does all that mean for scientists in the field? Well, If you're out prospecting for fossils and you happen to find an ammonite fossil in a layer of rock and you don't know how old that layer of rock is, the very fact that it contains ammonoids tells you that it can't be older than the Devonian or younger than the Cretaceous. So here's some good news. The last two columns are fairly straightforward. Let's start with the one labeled Important Geologic Events in New York. To give a quick example, according to this, the dome-like uplift of the Adirondack region, which is a mountain range located in upstate New York, began during the Cretaceous period. Last but not least, we have the Inferred Positions of Earth's Landmasses column. This is a series of maps showing how the Earth's major landmasses are thought to have been arranged at different points in geologic time. For example, according to the chart, 458 million years ago, North America straddled the equator.